Yeah, welcome everyone. Good afternoon all. So welcome to our today's webinar on hyperparameter tuning techniques, grid search, random forest and Bayesian optimization. Today we are going to explore why tuning is essential, how each method works and how to choose the right one for your use case. So why hyperparameter tuning matters means in machine learning models learn from the data, but their performance also depends on hyperparameters. Hyperparameters are the configurations who will set before training itself, such as learning rate, depth of tree, number of estimators, and so on and so forth. Tuning them can make the difference between the mediocre models and a top performing models. Poor tuning, like underfitting or overfitting. Good fitting means optimal generalizations has happened. So this is our architecture for a hyperparameter tuning. So here, as you can see, we are having start. So here start means we will define what we actually want to tune. Within our model, we are going to define what the model is, what we are going to tune, what are the different numbers are there. And then we will define our model in hyperparameter space over there, which will do what? Which will take the parameters to tune and the possible values and ranges within that range it should be present. Okay. Then there is choose the tuning technique, like whether to choose grid search, whether to choose random forest, whether to choose Bayesian optimization. Okay. So among this, we can choose any one of hyperparameter optimization techniques. Okay. So first we are going to understand about grid search path. So this is the architecture for your grid search path. Okay. So grid search. If we are going to understand what does grid search means, it is exhaustively tries every possible combinations of parameters from a predefined grids. Okay. So here, what are the different advantages and other things? So we are going to search from a predefined model. We are going to search for whatever the hyperparameters are set or whatever the different combinations of the parameters are there. Suppose commonly used with support vector machine, decision trees. These are all the models wherein we can use the grid search method. Okay, where we can apply this grid search method. Gradient boosting, decision tree, random forest, support vector machine. Okay, all these are the, even in the deep learning also, and even in the complex pipelines also. We can use these models. Okay. So what are the different advantages of using this particular grid search model is, it is extremely easy to implement and parallelize. Okay. It will guarantee finding the best result within the defined grids. What are the disadvantages then? It is extremely time consuming for large parameter spaces and works best for discrete hyperparameters. Okay, so what is the process? It will enumerate all the combinations, train model from each of this record, and then record will be generated. If you have 3 parameters, for example, each with a possible 5 values, so it will take 5 cube. Means 5 parameters or 3 parameters with 5 possibilities. So 5 cube it will do. It will have total 125 models to train. And then it will decide which model is giving you the best. Okay. Then there is a random forest model. Then there is random forest model. Is this? So here in the random forest, this is the random forest. Okay. So here, what is the definition for this? It will randomly select the combinations for hyperparameters instead of trying them all. Like earlier, we are trying all the models and then we are choosing from there. So here it will randomly select the combinations of hyperparameters. Okay. So here also we can use different methods like random search, all these things. Then what are the advantages here means much faster than grid search or continuous parameter spaces. It will surprisingly effective, often finds the near optimal solutions quickly. Then what are the disadvantages? No guarantee of finding the absolute best combination because we are randomly taking. We are randomly taking any two combinations and taking them, using them. Okay. So that is why we cannot guarantee that we will get the absolute best combination. What does the process means? It will randomly sample parameter sets. It will train the model and it will do what? It will do the record performance for all of these iteratively. Okay. When to use this model means when the parameter space is huge or a continuous, when you have limited time or resources, at that time you can use this random forest technique. Okay, less time, less resources. Okay, at that time you can use this random search. Then we are having the Bayesian optimization model. So here, what is the definition for Bayesian optimization means? Uses a probabilistic probability models, or also we can say it will take a surrogate model to predict which hyperparameters are most promising and then test them accordingly. Okay, so here the advantages is more efficient for expensive model evaluations, can fit better results with fewer trials as well. Okay, so it is also called a surrogate model. Okay, because it uses a probability models or probabilistic approaches. And the outcome will be iteratively improves when the parameter search efficiency will increase. Okay, so this is what. So when we are trying to compare these three models, okay, when we are trying to compare these three models, it will have a different for example here, compares the recording performance metrics, evaluating not just accuracy but also training time, generalization and stability. So how to select it? Select the best hyperparameter. So we can select the best hyperparameter set based upon our evaluation criteria. For example, accuracy, F1 score, area under the curve, or whatever the metrics is most relevant for our business problem. Okay, if our output variable is categorical, we will have a different evaluation matrix. If our output variable is numeric, we will have a different evaluation matrix. So based upon that, we can use a different type of hyperparameters. Okay. So choosing the right technique is very important. Like grid search model can be used for small discrete hyperparameter spaces where there is a plenty of computational power is there. Okay, when there is lots of computational power is available with us, then we can use with grid search. Then random search will use for large continuous spaces with moderate computational power. Then Bayesian computation is expensive models, needs efficiency and fewer trials only. So often we start with random search to narrow down and then fine tune them. We can use grid search and then we can go for a Bayesian optimization technique. Okay. Then let's go for coding part here. How we can do a coding here. So here we are installing sklearn libraries. From there, we are importing our data set, which is our load underscore iris data set, which is already present within your sklearn library, scikit-learn library. Okay, within the scikit-learn.data set, we already have this data set, which is a publicly available data set. So here for model selection, we are having this grid search and random search models. Okay. Likewise, we are going to use this model called as random forest classifier and matrix we are using as accuracy scoring. Okay, so you can see here by using this, we are having different hyperparameters here. Okay. Like for example, we are first loading our data set here. Okay. Loading our data set. This is a very small data set which is available and radial available in our data set. So you can see we are defining our model here. We are using n estimator and maximum depth as a hyperparameter here. Okay. N estimator and maximum depth. Okay. And this is our best parameter. It will give us the best parameters from here. Likewise, in the random search also, we are having n estimators and maximum depth as a hyperparameters. Okay, and we are giving that hyperparameters. Likewise, for the Bayesian optimization also, we are giving n estimators and maximum depth. Since we have used a very small model, it is giving us, we are running approximately 5 epochs, 5 iterations we are going to use here. Random search we are taking at 42. Okay, so this is what our model is. Very simple. Okay, so if someone will say that what is 50 and what is 100 and what is 50 or what is 200. So 50 or 100 is nothing but your number of trees because we are using a random forest here. So for that, this is our 50 and 100 is our, since we are using a random forest model, that is why. This is your tree, number of estimators. Okay, numbers of trees. We are taking try with 50 and maximum you have to take with 100. Likewise. So you can see here the results are like this. After running all 5 epochs, it will give you a result like this. Okay, the result from grid search. Okay, the result from random forest. Okay, likewise you will get the results, guys. Okay, so this is it from my side for today, guys. We'll see more things like this in our next lectures. Okay, let me open up PPT also. Yes. So this is it from my side for today. We will meet on next Monday with new topic. Thank you for joining. Thank you, guys. And this is where you can call or you can have inquiry. Okay. You can go and visit our offices also. Okay. Okay, guys. Thank you for joining. Thank you so much.